Well, it's good to be here. I'm pleased to see that as soon as anyone puts up a chat at a conference, people try and hack it with cross-site scripting. It's a good sign for a tech conference. I'm Alex MacCaw, and actually we're already off to a good start because in my last presentation at JSConf, I actually spelled my name wrong. So we're already off to a good start. So this slide is about the deconstruction of a JavaScript web app. And this JavaScript web app is called Monocle. Now, I want to give you a warning that this presentation is really code heavy. But pretty much every slide has code on it. And we're going to try and cover the whole app, which also means Ruby and CoffeeScript. So a little warning there. So what is Monocle? Well, it's a social news aggregation site. It's a lot like Hacker News, if you've used that. And you can go and check it out, monocle.io. And it's got a very pretty interface done by a designer friend of mine. And we have posts on the left, content on the right. And members can post new links and post comments. And notice we're extracting a bit of the post, a bit of text from the post, and we're also extracting a preview image. So today, I'm open sourcing this. So if you actually go to github.com/macman/monocle, you can download it. And I actually suggest you clone it right now, so you can actually go through the code as I'm talking about it. It'll give you a lot more context to the app. So I'm just going to give you a few moments to do that. If you open it up, you'll see this directory structure, and you'll notice that it's using Sinatra. The whole app is built on Sinatra, and most of the application code is under the app directory. So notice we also have this MVC architecture. We have models, views, controllers. In this case, we call controllers routes. Now, any client-side code is under app assets, and the file that bootstraps the whole app is called app.rb. Makes sense, right? This is what it looks like. Notice we're adding each route as middleware. Each route is its own Sinatra app, which is, I think, the best way of actually architecting Sinatra apps. So we are adding rack deflator there for gzipping support. We are adding rack CSRF there for cross-site scripting, cross-site request forgery attack prevention. And then we're adding our own routes. So we have the static for Sinatra's static files. We have the users for users API. We have the route, the posts route for the posts API. Comments for comments API. And the client. And the last one is actually what serves up our JavaScript client. So let's mosey down into the client and have a look at that. If you open up client.rb, you can see our client is bootstrapped in a few steps. First, any request to slash or slash posts is caught. Now, this rather ugly regex is what's doing that. There's actually a better way of doing this, but for now we're using a regex. So our JavaScript client will be served up at any of those URLs. So regardless of if they're 404s. So we don't actually check to see if a URL is valid at this point. We also check to see if the request is from a supported mobile client, and if it is, then we serve up a specialized mobile version of the app. So let's take a look at index.erb, which is being rendered there. This is what it looks like. We have one concatenated CSS file, one concatenated JavaScript file. We have nothing in the body tag, and everything is generated. And notice how we have defer on all the script tags. That makes sure that the page isn't blocked during rendering. And also notice that we have the setup.js file, which is actually going to bootstrap the app. It's going to instantiate the app with preloaded data. So we jump back to client.rb. We can actually see how these assets are generated. Anything under /assets is being served up by Sprockets, which is a Ruby asset manager. I use it everywhere. I highly recommend you use it. And the thing under /setup.js is generated by that little function there. It actually generates this JavaScript file, and it pre-populates it with data. You can see we're doing a SQL query here we're setting up some options, instance variable, and then we're rendering the setup.erb template. If we jump down into that, you can see that the ERB generates some JavaScript, and you can see all it's doing is requiring the app, and I'll get on a bit later in the talk about how require actually works, and then instantiating this app variable and appending it to the body. So if we go through the steps again, the browser navigates to slash, the client, which matches the client slash route, returns index.erb, browser fetches CSS and JavaScript, and then also the setup.js, and then the browser is instantiated, and that app is ready to go. So if we look at the front end, which is probably a better topic for this conference, it's an MVC structure too. We have controllers, we have models, and we have views. And in this case, the views are eco templates, which is a CoffeeScript templating framework or language. Actually, it's much easier to look at these controllers visually. We have one main app controller, which encompasses the whole app. Everything else belongs to that. Then we have two main subcontrollers. The sidebar. This is sidebar.module.coffee. And then we have posts, the post controller, posts.module.coffee. And then those two main subcontrollers themselves have self-controllers. We have the post details, and we also have post comments. Now, the key thing is to note that none of these controllers know about the other controllers. They only know about the subcontrollers, and they only know about models. So they're all really decoupled. And if we're going to talk about decoupling, we can't not talk about CommonJS modules. So if you notice, all those files on the front end have .module in the file name. This is because they're CommonJS modules. Now, what exactly does that mean? Well, CommonJS gives you require, and it gives you exports. And they're absolutely critical to building, I think, any large JavaScript apps. Without them, you get spaghetti code, and you get namespace pollution. So if you're using sprockets, then you can easily get CommonJS support by just adding the gem, sprockets CommonJS there. You just add that gem, and you're good to go. All you have to do is put .module in the file name, and we'll wrap it up as a CommonJS module. And essentially, this means the file is wrapped by some boilerplate code. And so it's executed in a local scope, and that boilerplate code also gives it the require function and the ability to export values and functions. So you have require at the top, you can require the modules, and then at the bottom of every single module you have an export, which basically exposes particular values. So if you now go back to index.module.rb, a few things should make more sense. Now this is the main app controller, if you remember. Everything else belongs to that. At the top, we're loading in all the controllers and models that we're going to need. And then we create this class called app, which is inheriting from controller, and then we're exporting at the bottom. When app is instantiated, we're using all the preloaded data passed in by setup.js, and then finally we instantiate our main subcontrollers, appending them to the page. And then if you have a look at post controller, it's very similar. We're doing the same thing. We're acquiring our controllers, we're listening to events, and we're appending subcontrollers. So it's fairly straightforward. Now, you may have noticed this controller object that we're inheriting from. What exactly is that? Well, if you've built MVC apps before, you may be familiar with controllers, the C part of MVC. A lot of MVC libraries call these views, like Backbone. I call them controllers. It's just terminology. Now, in Monocle, I'm not actually using Backbone. I'm not actually using Spine. I'm using this bastardization of both of them, which combines what I think is some of the best ideas from both of them. And I actually want to take you through some of this library because I think it's simple and has some neat approaches that you can apply to your own apps, even if you're not using this library. So this is controller.module.coffee, and this is found in the vendor directory. And this is the whole library right here. So a controller's job is scoping behavior to a single element. So every single controller has a single element called EL. Now that might be a little hard to read, it might be a bit small, I'm sorry about that. But you can see at the top, we're creating this element, and then we're creating a jQuery wrapped version of this element, which is called $EL. And then a lot of controllers have this class name property. If that's present, we're adding it to the element. We're adding that class to the element. And we're also going to listen to this removed event. I'm going to talk more about that later. Ignore it for now. So most of the controller functions are just delegating straight to that jQuery wrapped element. They're adding events, appending bits of HTML, that kind of thing. So the last two functions in this controller file are view and template. And they make it really easy to fetch an eco template and render it, and pass through helpers to it. So you can see that Sprockets creates this global variable called JST and attaches all the templates to it as properties. Now you can just fetch a template there. It'll be a function. You look it up by property. It'll be a function, and then you can execute that function, pass through context, and you'll get a string. All view is doing is actually decorating the context with any helpers that are present. So in other words, you render views like this. You pass at view a function name, a template name. It returns a function itself, and then you basically execute that function and you pass through context. So when it compiled, it rendered as a string, and then you just set the element's HTML to that string. Pretty straightforward. Now let's talk about something pretty neat. Let's jump back into the controller library and talk about that removed event. Now this removed event will actually be fired whenever that controller is removed from the DOM. And then our release function is called. Now this is a pretty useful little utility, because if you've registered any global event handlers, say listening to keyboard events, for example, in the controller's constructor, then in the release function at the bottom, you can unregister those events. Basically clean up a global event listeners. Other languages like Objective-C have the same kind of thing. So how does that removed event actually get fired? Well, we're kind of using this neat trick called jQuery special events. And you can have a look. This is basically the entire code to fire that removed event. And it's in jQuery.event.remove.coffee. So whenever jQuery removes an element, it actually passes it through this clean data function, jQuery.cleanData, which actually goes through and removes all the event listeners that jQuery has added to that element. And now this is useful because in some browsers like IE, event listeners aren't removed properly, and you get memory leaks. So jQuery has to actually remove all the event listeners from itself, and what you can do is tap into that functionality and define your own event. And your own event is called removed. And when jQuery tries to clean up this event from elements, you actually fire it rather than clean it up. And so then you automatically fire this removed event, and then it'll trigger the release function in controllers, and you automatically cleaning up controllers. And it's a very simple way of doing that. So we covered the controller library. Let's jump back into the posts controller. Notice we've got the state object now, which we're adding an event listener to this post property. Now, whenever I want to have global state in my app, I have to attach it to this state object. Now, I try to keep global state to a minimum. And actually, in Monocle, the only properties in global state are the current user, the current environment, like development or production, and crucially, the currently viewed post, which is what we're listening to here. So whenever that changes, the controller is going to re-render itself. If you have a look at the state module, state.module.coffee, it essentially looks like this. We have a state class that inherits from model, and notice at the bottom that we're actually instantiating that state class. There's only ever one instance of that state class. So there are other models too that represent all the major data structures in the app. We have posts, comments, etc. These all hold data-related state rather than view-related state, which is the realm of the controller. And if you have a look at the model, post.module.coffee, it looks a bit like this. However, I'm going to stop right there because it's unlikely you're going to be using this custom MVC framework. It's got no following or support. It's just something I like tinkering around with. So I won't expand on much of this part of the app. But what I do want to cover is parts that you are going to reuse that will hopefully be useful in the kind of JavaScript apps that you're making, such as scoping CSS. So let's take a simple controller. This is the landing page. This is displayed if no post is selected. Notice at the top we have this class name property. Pretty much every controller has this. When instantiated, this class name will actually be added to the controller's element. Every controller has a corresponding CSS file. So posts landing.module has this post_landing.css.style CSS file. Now, I'm not actually using stylus. I'm not actually using plain CSS. I'm using stylus for this. If you're not familiar with stylus, it's just another CSS preprocessor like less or Sass. But the key thing here is that notice that everything in this CSS file is namespaced by the class name property we set earlier. So all the CSS is specific to that controller. So my advice is to make CSS as specific as possible when you're making large JavaScript apps. Don't worry about dryness too much. Repetition will be removed a lot by gzipping. There may be a performance impact for this, but again, you can approach that later if it's a problem. Now, if a controller has subcontrollers, then you may find that a controller CSS is actually affecting all those elements that are appended to it. And this just means you need to get more specific. You can use the right-hand bracket here, and this will only select the direct children of this element. I want to talk a bit about how we created this scrollable list and the sidebar of Monocle, and also how we added keyboard shortcuts to it. If you use the up and down arrow keys, you'll notice that they work, right? In Monocle, you have this infinite list of posts in the sidebar. Now, this list is actually rendered by the posts lists controller, and each list item is rendered by the posts item controller. Makes sense. If we open up the posts lists controller, postlist.module.coffee, we can step through the execution flow and see what's going on. Okay, so the controller is instantiated, and we're calling render immediately. So render just cleans up the DOM, basically empties all the elements in that controller, and then calls add all. And then add all will iterate through this collection. The collection is basically just an array of posts instances. And then for each one, it'll call this add one function. And that just appends a new post item to the controller's element. Now, the post item controller will take care of rendering itself, rendering a little section of that list. And it will take care of re-rendering it if the name changes, or if the upvote score increases, that kind of thing. And it will also take care of listening to click events when people upvote posts. Now, if you remember earlier, we had this global state with a post property. So if we actually listen to that, we can actually highlight whichever post is currently selected. So we're listening to the change post. Anyway, we can get rid of the little video at the bottom. It's kind of blocking the code. So we're listening to the posts property on state, and we're calling the set post function whenever it changes. Now, if we define set post function, what we can do is we're setting this instance variable called @post, and then we're calling setActive. And setActive will iterate through all the DOM elements in the list, remove the active class, and then if there is a post, it'll try and find that using a data ID selector and add the class of active onto it. And then we've got this interesting function, scroll into view if needed. Now, what exactly does that do? Well, it's actually a little-known WebKit function. It's on elements inside WebKit. And it does what it says on the tin. So in this case, I've actually abstracted it to a jQuery plugin, but it's actually just a method on DOM elements. And if you call it, it'll scroll that element into the view. It's super useful. And in other browsers that aren't WebKit-based, then you can just use the shim. So this ensures that whatever current element is selected, it'll be visible, which is important when you're doing up and down keyboard navigation, which is the next section. So we can add up and down keyboard bindings to the sidebar controller. So again, if you open up sidebar.module.coffee, we can add a global event listener for key down in the constructor here, and then we can clean that up in the release function. Remember, that's quite important because if the controller is removed from the DOM, we want that to be cleaned up. Now, we actually have a key mapping property on here. Now, you can see that that's just mapping a key code to a function name. So 38 is the up key, 40 the down key. We also have this key down event listener callback, which is what we were listening to. It's listening to keyboard events in the document. So basically, all it does is check to see if there's a key mapping for a specific event key code, and if there is, it'll execute it. So in this case, we have two callbacks, 38, 40, up and down keys on the keyboard. So down arrow equals down key, which in turn calls next post. Notice that all we're doing is looking to see which item has an active class, and then we're using jQuery's.next and .previous functions to try and find whatever the next to previous element is, and click on it. And we just basically simulate a click. It's as if the user clicked it themselves. But we have a problem here. We have a scrolling conflict because the browser also uses the up and down arrow keys to scroll the contents. So if you remember, we're actually managing the scrolling of the sidebar ourselves with scroll into view if needed. We could just cancel all the scroll events, but the scrolling needs to happen in other parts of the app. So these are actually the two main scroll areas. We have the sidebar, we have the main content. So we basically need to figure out which area has focus. If the sidebar has focus, then we can just cancel scroll events or that are associated with the up and down arrow keys and do the scrolling ourselves. If it's if the main part, number 2, has focus, then we need to not scroll the sidebar, and we just need to let the browser actually scroll the content itself. So if you think about it, the active area is whichever area was clicked last. So I tried to find a browser API to do this. It doesn't exist. I tried for hours. You'd think it would exist. It's kind of a logical thing to put in the browser, but it doesn't. So we're going to have to do this ourselves. We can create this jQuery.activearea.coffee jQuery plugin. And all it does is you can mark up active areas in your app, and it will listen to click events on them. When a click event is activated, it's going to call this active area callback, and that is just going to set the current variable. And then we can have another function that just checks to see if a specific DOM element is the current one. So let's mark up our active areas in the posts and sidebar controller. These are our two main areas that are scrollable, if you remember. Now these are going to be listened to. Now we go back to our sidebar controller. What we can do is check to see if the element is active. If it's not, just ignore the event. It's that simple. I want to talk a bit about dynamic pagination. Now this is a pretty tricky problem, actually. So in Monocle, the sort order of posts on the left side is actually dynamic. A single vote could cause a post to rise up or down, and also there's a time decay, which also affects rankings. But once the user has scrolled to the bottom of this list, we need to figure out what the next page is, fetch it, and add it to the list. We need to figure out the next page even if it involves not putting duplicates in this one, even if the list has already changed. So what do other people do? Well, what does Hack and Use do? Well, it actually stores every single possible sort combination in a closure. And as you can imagine, this gets bigger and bigger. is exponentially huge as you have more posts. So what happens ultimately? Well, the garbage collector kicks in, and then it cleans up those closures, and that means you get expired pagination links. You may have seen it on Hacker News. It's kind of shitty. Reddit kind of does the same thing, except it shows even more duplicates on the second page. So how do you solve this? Well, I was on holiday with Jake Thornton recently, and he told me what he did with Medium, and it's very simple, but it's a very good, I think, hack to this problem. So in other words, what you do is whenever you fetch the next page of posts, you send an array containing all the previously fetched post items, IDs, so the ones that you already have on the page. You send that to the server, then whenever you return posts from the server, you ensure that those IDs are not referenced from the resulting set. So this is what the Ruby code looks like. You find the popular posts, you exclude any which have an ID of the array that's passed in, and then you return them. You limit it by 30, and you return the next page. It works great. That's the solution to that problem. Real-time streaming. Well, actually, Monocle uses real-time streaming to keep its interface up to date. So if you upvote a post, or add a new comment, or add a new post, those things are going to be reflected instantly across everyone viewing Monocle. How do we do this? Server-sent events. Now, this is the easiest form of real-time streaming, I think, on the browser. If you only need PubSub, and you don't need bidirectional communication, use server-side events. They are so much simpler than WebSockets. They don't have a binary protocol. It's very simple. In fact, I can show you the protocol right here in a Ruby example. So all you have to do is make sure that responses contain this content type of text/event-stream. Then you need to keep the connection open. Then to write to a stream's connection, you just write data, colon, and then the message, and then new line, new line. And that is the entire protocol. That's what WebSockets should have been. But yeah, luckily we have server-sent events. So back in the day, I used to have this project called Juggernaut, which actually did real-time streaming over Flash. And when server-side events came along, I called it a day. I was like, the browser has fixed this problem. We can deprecate Juggernaut. Problem is solved. However, what I realized is that people want abstraction. And I wanted abstraction from Monocle. So I made this thing called Sinatra-PubSub. It's a gem. Anyone can use it. And it'll deal with channels. And it'll deal with cross-origin request headers. And it'll deal with keep alives and Redis PubSub. And it's kind of geared towards using it on Heroku. So here's another example of using this library. Here we're publishing a talk message to the TIG channel, and we have a client subscribing to it. So on the client side, you just use this event source object, and you just pass it through a URL, and then it will start streaming from the server. And this /subscribe route is actually what's set up by Sinatra-PubSub. So that is all you need to do to stream this talk message to the client. And in fact, if you go to JSConf.Asia, I set up this simple example of this. It'll just stream these tick messages. It's pretty boring, to be honest. It doesn't do much more than that. So I'm telling you all of this because Monocle has the streaming setup server under stream.monocle.io. And if you look at the stream module in vendor, I've abstracted event source a bit, and I made it pass all the messages that it actually gets. So I made it pass through JSON. And then I'm firing my own event on this stream module. So if you have a look on the server side, notice we have, this is an example of how a post is voted. We have this publish method right here. And this publish method basically interacts with Sinatra-PubSub, writes the message to all channels. In this case, we're publishing that a post got voted upon. And now if we have a look at our client side again, it's just kind of cut out, we can perform the appropriate action. We can listen to the post's vote event, and then we can, in this case, what we're doing is we're just refreshing that post or fetching it again from the server, and it'll have the updated vote count. So in other words, you can add this kind of real-time streaming to your app very, very simply. It'll probably only take you half an hour. So adding SEO to Monocle was pretty easy. Google have this Ajax crawling specification, and basically all we need to do is set up a robot-friendly version of the site, one that isn't rendered with JavaScript. So if you go to this URL and you include the _escaped _fragment _ exactly as shown there, you'll see the robot-friendly version of the site. And it looks a bit like this. It's just a plain HTML. There's no JavaScript in there or anything else. Now, the key to making Google fetch your page like this is this meta tag. You just put it in your main site, and what Google will do as soon as it comes across this meta tag is it will request the page again, and it will add that _escaped fragment _ to the URL. What you can do on the server side is just detect if that is there, and then you can render your spider-friendly page. So you simply implement a route that checks for it. And in fact, in Sinatra, you can do this in a little nicer way. What you can do is add a route condition. So this route will only match if escape fragment is in the parameters. On the client side, in the rendered ERB, it looks a bit like this. We just have plain HTML. We have an H1 tag, important for SEO. And we have a meta description tag, again important for SEO. That is what is displayed inside Google's search engine. And then that's it. We have SEO. If you go to site:/monocle.io, if you just Google that, you'll see there's a bunch of Monocle has been indexed by Google. It works pretty well. So I want to make sure that the user doesn't quit the tab when certain Ajax requests are in the fly, such as creating new posts, voting, that kind of thing. So what we can do for this is use the _before_unload event, which we can use to warn the user they may lose data if they continue closing the tab. Now this event is actually really a pseudo event. It's not really an event. It can only have one handler, and it's called just before the page closes. And now if a string is returned from this event, then that string will be prompted to the client, and then they have the option to close the tab or not. So that's the only control you have for security reasons. Now jQuery has this active property. It's undocumented, but it'll an active property is basically an integer count of the current Ajax connections. So if there's more than one connection, then this flow control will return true, a string will be returned, the user will be prompted to see if they actually want to close the tab. Now, actually, I found a bug in Google Chrome where the cache gets completely balked if you use _before_unload. So the only way to actually work around this is set _before_unload only when the page is in an unloadable state. So if you have a look at jQuery.onClose, this is another plugin in the vendor directory, which I wrote for Monocle. You can see that if whenever there's an Ajax request being sent out, we're incrementing our own active transforms integer, and then we're adding the handler if there are active transforms, and then we're doing the opposite when the Ajax request is complete. Lastly, I want to talk about the wake event. So we want to make sure that the computer wakes up, the browser fetches the latest posts from Monocle. Because people keep tabs open for a long time, we don't want data to get stale on there. But there's no browser API for this. There is a browser API for page visibility, but it actually doesn't help here. So we have to do it ourselves. I've written this plugin. Again, actually it's called jQuery.wake.coffee, not .js. But what it's doing here is using timers to detect if we think there's been a page sleep. Now, since timers execute at a relatively predictable interval, we can check each iteration and see if it matches, if the current time is what we expect it to be. If it isn't, the likelihood is that the computer probably paused the timers during a sleep, and then we can execute our wake event. Now, all we have to do in our index.module.coffee is listen to this wake event, refresh the posts, and we're done. I want to thank you very much for listening to this talk, and if you have any questions, I'll be happy to listen to them.
All right, thank you so much, Alex. Now, we have time for a few questions before we go on a break. Does anyone have any questions? Please raise your hands. Oh, all right, there's a gentleman here.
So I've just got one, going back quite a bit into the talk with your issues with pagination. I'm just wondering, have there been any issues, whether you've run into them or even just theoretical, with the URLs getting too long by requesting so many existing post IDs?
Getting too long? Yes. Yes, it's well spotted. URLs have a set length. And if you put too many IDs in that, then you're going to have problems. That's why you use a post.
Okay.
Yeah.
So use a post for your
pagination
request.
Yeah.
That gets on that.